Bonjour. So, this is the final video for the trigonometry chapter, and in this video we will quickly revise what we have learned, and I will introduce to you certain topics of trigonometry that we haven't learned and that you might learn in future years. Okay, so when we started, I defined trigonometry as a branch of mathematics that deals with ratios of lengths of sides of right triangles, and we said it's very useful in science and engineering. Now, this is the basic definition of trigonometry. There are more complete and more comprehensive definitions that are slightly different. So I had said that it is useful in solving triangles, and we have done this for a few types of triangles, and we will again look at this in this video. Okay, so the first thing we learned was the name of the ratios, cosinus, sinus and tangent. Then we learned what their definitions are. Here, côté adjacent sur hypoténuse for cosinus, côté opposé sur hypoténuse for sinus, côté opposé sur côté adjacent for tangent. And then we learned how to use a calculator to obtain these ratios, because these ratios are stored in the calculator. And then we came to angle complémentaire, where we learned that sinus A is equal to cosinus B if A and B are angles in a right triangle. Okay, sinus of A is equal to cosinus of 90 minus A. Similarly, cos A is equal to sine of 90 minus A. Then we looked at the range of values that these functions can take for two angle A aigu. Now this aigu is important. 0 to 90 degrees is what is meant by an angle aigu, in French acute angle, and we saw that cos goes from 0 to 1, sine goes from 0 to 1, you even drew graphs for these, and tangent goes from 0 to infinite. This is for angle aigu, acute angles. Then we took some special identities. We found out that sinus over cosinus is equal to tangent, and we also found out that sinus carré plus cosinus carré of any angle is equal to 1. So these are identities. Remember what are identities? Identité, that means they are true for any value that you plug in there. Similarly, sine of A over cos of A is equal to tan of A is true for all values of A. C'est une égalité qui est vraie pour tout valeur de A. This is similar. Then we also looked at inverse trigonometry ratios, arc sine, arc cos, arc tan, which is what we learned here. Sine of A is equal to that, and that led us to these values. Arc sine of V is equal to, it's an angle. So knowing the ratio, can we find out the angle? Again, we use a calculator to do that. And now we come to solving triangles. We use trigonometry to solve triangles. So now I didn't say it when we were doing it, but there are four different forms of triangles that can be solved. So here, this was the first one we started with. I gave you an angle. I gave you, two angles, here and here, and one side, and we had to find out the third angle, which is very easy because we know the sum of angles in a triangle is equal to 180, and we had to find out these two sides. That is not possible without using trigonometry. The solution, as many of you discovered, was to draw an author from there Now that you know that this angle is 60 degrees, then you can find out that length, and you can find out that length, and because you know that angle, because you know this is 50 and 60, 110, that is 70 degrees, and you know that length already, then you can find out that length, and then you can find out that length, and then that way you have solved the triangle. Solve meaning finding all the sides and all the angles. This is a format which is known as A, angle, côté, angle. This is what has been given to you. Angle, side, angle. Then we looked at this format which is côté, angle, côté. So here I gave you two sides and the angle between them, and I asked you to solve this. And this too you solved by drawing an author there, and then you could find out step by step all the remaining angles and the remaining side. Now in certain cases, as you discovered, the author comes outside the triangle, but that doesn't make it any more difficult to calculate. We didn't do this particular format. This is assez, that is, we are given an angle and then we are given two sides. So here the angle was between the two sides that were given. Here the angle is outside of the two sides that are given, the lengths. So if this is 40 millimeters and this is 80 millimeters, then you have, and this angle is 60. How do you find these two other angles, and how do you find this unknown side? And again it's similar. If you think about it, if you drop an author there, you'll be able to solve this also. And now we come to the fourth and final form of solving a triangle, and which you haven't done, is this côté, côté, côté. So I give you three sides, that this triangle has 20, 22 and 29 units length, the three sides. What are the angles? Now with your knowledge, with what we have learnt in this chapter, you simply cannot solve this, because you need to know at least one angle. Even if you divide this into two right triangles, if you drop an author from there to there, you don't know any angle, and since you don't know any angle, there is no trigonometric function you can use. So this you cannot solve with your current knowledge. So I will tell you how to solve this. I will not prove it to you, I will solve you. There is a law of cosines. It is called a law of cosines. It basically says that if you have a triangle ABC, where the opposite side to angle A is length is A, opposite side to angle C is length is small c, and here similarly this length is B. This is a very common notation for drawing triangles. So if you have A angle, then the opposite side, the length is small a. If you have C angle, the opposite side is small c, and if you have a B angle, then the opposite side, when I say the opposite side, I mean the length of the opposite side, is small b. So law of cosine says that angle A is equal to arc cos of B square plus C square. Remember, these are all lengths in the same units. So you have B square plus C square minus A square divided by 2 into B into C. If you take this and you take the arc cos of this, you will get angle A. Similarly, the same thing applies for angle B, and the same thing applies for angle C. This is known as a law of cosines. It's very useful, and it's the only way you can solve this particular triangle where three sides are given but no angle is given. So you use this to find out A, you use this to find out B, and you can use this to find out C, but it's simpler to just subtract 180 minus A minus B to get C, 180 degrees. So this is the way to solve this particular triangle where three sides are given but no angle is given. Now, where did I get this from? It's fairly complicated to prove this, but it can be proven. If you are interested, you go to the internet, go to Wikipedia and type in law of cosines, and then there are several different proofs that are given, and one of them is actually understandable by you, because because of the limited knowledge you have. There are many proofs. Many of them require more maths than you currently know. Okay, so this is for solving triangles. So again, as a in-video problem, I have a triangle with 6, 8 and 7. Please find the angles A, B and C and submit to me. This is just to make sure that you have watched and you are watching the video. Okay, now we come to something that we didn't really cover. Obtuse angles. What is obtuse angles? Angle obtuse. O-B-T-U-S. Without the in French. I think that's the way it is. It means obtuse angle, an angle which is greater than 90 degrees and less than 180 degrees. So now we saw that, remember this chapter is called Utiliser la trigonométrie du triangle rectangle. But trigonometry also applies for outside the right triangle. So here you can get, when we looked at, let me find that, when we took that pour tout angle A aigu and we found this, well actually this is limited to aigu. For angle, any angle, say 160 degrees, 140 degrees, you can still take trigonometry functions, but you cannot define them the way we have defined them. For example, trigonometric function cannot be defined for obtuse angles using ratios of sides of a right triangle. So if you have a right triangle, this is a right angle, this is one side, this is the other side, and if I take an obtuse angle here, say 120 degrees, then I won't even get a triangle. The triangle will not even be complete, because in a right angle triangle you have to have two acute angles. But in this case, I'm trying to find out the trigonometry ratio, which will give me the ratio for obtuse angles, and I cannot even complete a triangle. So since I cannot complete a triangle, I cannot use the ratio of sides to define the trigonometry ratios. So what happens here? Trigonometry functions for obtuse angles exist but are defined differently. How are they defined? I'm afraid we don't know enough maths to go into them. If you like, you can look it up on the internet, but I'm afraid you will not really understand. And why are they defined? They're defined because you want to solve things, because you want to do calculations. Trigonometry is incredibly useful in science and engineering, and it's not limited to solving triangles and geometry, but a whole host of other things. For example, in electrical engineering, trigonometry is very useful. In fact, the current that comes out of the sockets in your house follows what is known as a sine wave. It is related to the trigonometric function called of the sine, the sinus. Anyway, now another thing is that trigonometry functions can have negative values, which we saw that then it's not true for acute angles, for angle aigu, because there we saw that sine can only go 0 to 1, cos can only go 0 to 1, tan can go 0 to infinite. But we didn't talk of negative values. But trig functions can have negative values for obtuse or reflex angles. So just let me add an S there. Trig functions can have negative values for obtuse or reflex angles. Now you're wondering, Kimda is saying obtuse, or we learned what is obtuse. What is reflex? Okay, so reflex angles are angles which are greater than 180 but less than 360 degrees. So the first 90 degrees, 0 to 90 are obtuse angles, 90 to 180 are, 0 to 90 degrees are acute angles, 90 to 180 are obtuse angles, and 180 to 360 are reflex angles. So for example, if you plug this into your calculator, sine of 225 degrees, you will get minus 7.07. You will get a negative value. Similarly, if you do cos of 120, you will get minus 0.5. If you do tan of 300, you will get minus 1.73. So this is something that we haven't learned, and you may learn later on in future years. Okay, another topic that we haven't covered are trigonometric identities. These are two words. I didn't leave enough space. And for example, we learnt one. We did one. You found out in the last assignment that a over sine a is equal to b over sine b for any triangle. And actually, by extension, this is also equal to c over sine c, because if you took B and C and angle B and C, you would get the same thing. It's a similar way. Now this is an identity which is true for all triangles, for all angles A, B, C. Similarly, this is a really funny one. Sine of 2A is equal to 2 of sine A into cos A. Now you see here we have A, small b, small c. This is for a triangle, correct? There is no sides at all, there's only angles. So this identity is saying that sine of 2 of A, twice an angle A, is equal to twice of sine A into cos A. So let's say if A is 39 degrees, it is telling us sine of 78 is equal to 2 into sine of 39 into cos of 39. So this is an identity. Identity again means an egalite, an equality that is true for all values, or for all values in a range that is given. In this case, it is true for all values of A. You can try this. You can plug this into your calculator. You can do this right side on your calculator, and you will get membre gauche est égal à membre droite. Okay, so another one is again similar. Sine of 2A is equal to 2 into tan A over 1 plus tan square A. Now each one of these can be proven using algebra and advanced mathematics, and we have seen 3 examples of trigonometric identities, 1, 2, 3, but there are literally hundreds of them, hundreds. You can go to Wikipedia and do list of trigonometric identities, and you'll get a long page where you'll find many trigonometric identities, some of which will be so complicated you won't even understand them, let alone understand how to solve them or how to prove them rather. Okay, and finally one topic that we haven't covered is radians. Remember on your calculator there is the gray, grad and radians. Grade in English, degrees, grade and radian. That grade is completely useless, sorry. But this radian is very important. This is an alternative unit for measuring angles. So far we only know we measure angle in degrees. One whole circle is divided into 360. But radian, 360 degrees. But radians are an alternative unit for measuring angles. Just like there are alternative units for measuring lengths. You have millimeters, you have inches, you have miles. So similarly for measuring angles you have 3 basic units. One is the degrees, which we know so well. The second is grade, which is really not useful. You'll never come across it in real life or in science or in engineering or in anything else. And the other one is radians, which is very useful in science and engineering. Okay, so I'll just explain to you what a radian is. So you draw a circle, and when you draw it, you can perhaps draw it better than I did. You mark out the radius, and then along the circumference you measure r. Okay, so let me show this. So this is r, say r is 2 centimeters, then along the radius I will measure 2 centimeters. Where that point comes, I will join it to the center, and this angle theta, Greek letter theta I call it here, you can call it anything else, is equal to 1 radian. Basically, if you take the radius of any circle and you mark it out there, you will get the same angle every time, and that is 1 radian. That is the definition of a radian. Now we know that the circumference of a circle is 2 pi r, the pr. That is the circumference of a of a circle. So that means 2 pi r corresponds to 360 degrees. So 360 degrees is equal to 2 pi radians, because you have, for every length of r there, you have 1 radian. So basically, therefore, you can say 1 radian is equal to 360 divided by 2 pi, which is approximately 57.3 degrees. So this is the conversion factor to convert between degrees and radians. 1 radian is equal to 57.3. I'll give you just one example of where radians are useful. Remember, in when I explained to you what sine, cos, and tan means, and you asked me, I think one of you asked me, what is a function that defines it, and then I sent you some links to some web pages, or I think some screenshots to show you that the calculator doesn't actually store these values, it calculates them on the fly, and it uses infinite series, so trigonometric infinite series. So what you can do, what it does is, it uses, if you put in say sine of 1, and this uses radians, so that's why radians are useful. So if you wanted to find out sine of 60, you have to first convert 60 into radians. The calculator does that internally, and then it uses this infinite series. An infinite series is one series that never ends. So here you have, let me put 3 dots there to signify it doesn't end. So you start with x minus x cube divided by 3 factorial. This is a factorial sign. It means 1 into 2 into 3, plus x to the power 5 divided by 5 factorial. This means 1 into 2 into 3 into 4 into 5, minus x to the power 7 divided by 7 factorial. Here it means 1 into 2 into 3 into 4 into 5 into 6 into 7. So you see it alternates, minus, plus, minus, plus. Here it is 3, 5, 7, 9, next will be 11, and 3 factorial, 5 factorial, 7 factorial, 9 factorial. So the more terms you take in your calculation, the closer you will get to the actual value of the sinus function. That is how the calculator does it. It does it so fast that you really don't realize it. You think it has just looked it up in a table. And there is where we end this our introduction to trigonometry. We have covered a lot. We have spent more time on this chapter than on any other chapter, but you have learnt it is interesting, and it is a very powerful tool in solving triangles, and as you may see later on, in other aspects of science and engineering. Okay, send me the in video problem. There was only one. This was it. This one here. The length of, find out the angles given this triangle. Find out its angles using the law of cosines. And I do suggest that you can look up list of trigonometric identities in Wikipedia, and if you want to find out how to prove this, you can also look up law of cosines in Wikipedia. They give several proofs, one of which I think it's the first one you will be able to understand. Okay, I thought it would be a short video, but it has ended up as 24 minutes, and this is the final video for this chapter. We will start a new chapter tomorrow or day after.